In a traditional machine learning model, which is what we've studied so far, how do the input features that we feed in for a particular problem affect the output that the model produces, the prediction the model produces? We've come a pretty long way in this course. It's now time to move on to the cool stuff, to the interesting stuff, to the stuff which is almost magical. Neural networks in TensorFlow. TensorFlow was explicitly built to make using neural networks easy, and we'll see how that is set up. So far, we've learned the basic building blocks of TensorFlow: placeholders, constants, sessions, graphs. We've learned how to work with images. We've built regression models. Here is what we'll cover in this module. We'll learn what neural networks are and how they work. They are representation based machine learning algorithms which determine by themselves from the data what features matter. Neural networks are made up of active learning blocks, which are the building blocks of neural networks called neurons. A neuron is nothing but an activation function, and within a neuron, there are actually two different and simple functions that we apply to inputs: the linear function and an activation function. We'll understand the role of each and how they come together to build a complex neural network. We'll then understand the various factors that we have to take into consideration when we design a neural network. We'll talk about vanishing and exploding gradients and how they can be mitigated, and how the proper choice of activation function is extremely important if you want to have a neural network that is sensitive to changing input. We'll also talk about common problems which arise when you use neural networks for your machine learning solutions, one of which is overfitting. Overfitting basically means that your model performs extremely well on training data but poorly on data in the real world, that is, test data. We'll see how these can be mitigated using techniques such as dropout. In order to understand neural networks, let's take a teeny step back and understand what really machine learning is. Our running example in this course has been that we want to use a machine learning model to perform a simple classification task. We want to determine whether whales are fish or mammals. What you'll do is set up a machine learning model, a classifier which has been trained on a huge corpus of data and which is ready to perform this task. The input to this classifier should be the features that you want to tell it about the whale, and the output of this will be whether it's a fish or a mammal. In order to set up and use your classifier, there are two phases involved. The first is the training phase, where you're actually tweaking the model parameters to get the best possible model. This is where you feed in a large corpus of data that has been classified correctly, and this correct classification is used to change your model parameters. The second is the prediction phase. This is where your model is actually used out in the real world on real data. You'll feed the model in some input and hopefully get the correct classification. This is if your model has been trained well. You'll start off by initializing your model parameters to some random values and then feed in a whole corpus of classified data. Now, because the corpus is already labeled with the correct answers, your model will basically output a classification. Compare this classification with the correct label that's associated with every input instance that you've fed in, and this comparison forms a feedback loop into the model. This feedback is called the cost function. This feedback to the model forms the core of our training phase because this is what allows us to tweak the model parameters to improve the classifier so that it makes classifications more accurate. Once we have this fully trained machine learning based classifier, we'll feed it some characteristics of a whale. If we feed it information like a whale breathes like a mammal and gives birth like a mammal, based on its model parameters, it's very likely to predict that the whale is a mammal. This prediction happens to be correct. But now, this prediction is very sensitive to what features that you've fed in to this particular machine learning based classifier. Let's say you were to feed the same classifier with the same model parameters a different set of information. If you had directed the attention of this traditional machine learning based binary classifier to the fact that the whale moves like a fish and looks like a fish and lives in the sea, then it's likely to predict that the whale is indeed a fish. Traditional machine learning based classifiers, such as naive based support vector machines and others, are very sensitive to what features you input into the classifier, what features you ask it to pay attention to. Another way to phrase this is that the input feature vector, the features that you direct the attention of your ML based binary classifier to, determines the output classification, that is the output label of your machine learning model. Now, if you were to go ahead and tweak the input feature vector, the machine learning model wouldn't know better that these are not the features that determine whether a whale is a fish or a mammal. These are not the features that are important. It looks to you for direction to know what features are important, which is why in this situation, the classification that it outputs is likely to be wrong. Traditional machine learning models rely on experts, that is, us as data scientists and developers, to specify what features are important, what features in the underlying data it should pay attention to. Now, if we end up specifying a different set of features, the output of the machine learning model will be completely different. If we focus on the fact that whales give birth to young and they breathe like mammals, then our classifier will say that a whale is a mammal. But if our feature vector says that whales swims like fish and lives in the sea, then our classifier will basically classify whales as fish wrongly.